Hi everyone, welcome to my YouTube channel. My name is Bong Yick Ling and my metric number is 73381. In this video, I would like to talk about the application areas of thermodynamics. First of all, thermodynamics refers to the energy and energy transfer involving physical matter. The matter and the environment related to the matter are known as a system, and everything outside the system is called the surroundings. There are two types of systems, namely open system and closed system. Open system is a system that allows energy transfer between the system and the surroundings, whereas a closed system is a system that does not allow energy transfer between the system and the surrounding. Principles of thermodynamics is applied in wide areas, for example, spacecraft, aircraft, boats, power plants, refrigerator, food processing, and many more. Hence, it is obvious that the knowledge of thermodynamics is very significant to keep things functioning, to improve the quality of life, and also make things more convenient for us. In other words, we can also say that thermodynamics is rooted in our daily lives. Take, for example, a rice cooker, an electrical appliance that I believe most of us have it at home. This rice cooker applies the principles of thermodynamics. Now, I would like to talk about the first law of thermodynamics. Before that, we know that energy is a thermodynamic property. So the first law of thermodynamics is actually an expression of the conservation of energy principle. It is stated that energy can change from one form to another form, but the total amount of energy will remain constant. In other words, energy cannot be created or destroyed. This principle can be shown in the mechanism of this rice cooker. When we want to cook rice, we have to insert this plug to the socket and turn on the switch. Then, electrical energy starts to flow. Electrical energy is then converted to heat energy to cook the rice. From this conversion of electrical energy to heat energy, it can be shown that energy can change from one form to another form. In this case, electrical energy is converted to heat energy to cook the rice. Next, I'm going to talk about the second law of thermodynamics. The second law of thermodynamics states that energy has quality and also quantity. And the process occurs in the direction of decreasing energy. This means that energy is transferred from a region with higher energy to a region with lower energy. For example, if I put a bowl of hot rice on the table for a period of time, the temperature of the hot rice will gradually decrease until it reaches a thermal equilibrium with the surrounding temperature. In this case, it is the room temperature at around 25 degrees Celsius. Thermal equilibrium simply means that a system has reached a stage whereby there are no temperature differential, which is the driving force for heat flow. In other words, there is no net heat flow. So from this, we can see that heat energy is transferred from the rice to the surrounding, which have a lower temperature compared to the rice, until they both reach a same temperature. This phenomena is known as thermal equilibrium. Also, the second law of thermodynamics can be visualized in the cooking stage of the rice cooker. That is, when we turn on the switch, electrical energy starts to flow towards the heating plate in the rice cooker, where electrical energy is transferred to heat energy. Initially, the heating plate in the rice cooker has no energy to cook the rice. Only after the switch is turned on and electrical energy starts to flow, this makes that this area is a region with higher energy and the heating plate acts as a region with lower energy. Hence, you can see that energy is transferred from a region with high energy to a region with low energy. Next, I would like to talk about the mechanism of the rice cooker. First, here's a diagram showing parts of the rice cooker. The rice cooker consists mainly of a main body, some buttons, thermal sensing device, electric heating plate, and also an inner cooking pan. Cooking rice happens in 4 stages. First, sitting in water. Second, boiling. Third, absorbing water or steaming. And lastly, resting. A simple rice cooker will usually warm up the content by transferring heat from the heating plate to the inner pan. And the metal used are conductive metals like copper and aluminum. This is because they are conductive and can transfer heat easily. This also reduces the cooking time. Cooking rice is simple. First, the water in the cooking pan will be boiled to 100 degrees Celsius. Once it's boiled, the temperature should be stable until all the water is absorbed by the rice. Then, the temperature will start to rise. This rise in temperature will be sensed by the thermal sensing device, and this switches the rice cooker off or switch it to a warming cycle. At this point, the rice has been cooked. Moreover, the rice cooker transfers heat by the means of conduction. Conduction is the transfer of energy from a more energetic particle to the adjacent less energetic particle. The substance itself does not flow. Heat is transferred internally by the vibration of atoms and molecules. In conclusion, it's clear that a rice cooker applies the principles of thermodynamics. We can see how energy is transferred and how it actually works. For example, the rice cooker functions relating to the first and second law of thermodynamics. Okay, so this is the end of this video. Hope you learned something from this video. Thank you for watching. Bye!